Hello viewers, welcome to another interesting video that concerns with the previous video. In that video, we discussed about hydrolytic resistance test. We discussed that when glass is in contact with a moist environment for several months or at high temperatures, water in the product gets vaporized and get condensed when come in contact with the surface of the container. Thus the surface of glass becomes wet. This water which come in contact with the surface of glass container dissolves alkali salts and removes them from the glass. This process is called as hydrolysis of glass. We also discussed that we are expecting from the glass container that its inner surface must resist or oppose the hydrolysis of glass, that is leaching of alkali, and that is called resistance to hydrolysis. Further, we discussed that resistance of glass surface can be improved by treating the surface of glass containers with either silicon or sulfur. But when treated glasses are used, we have to check whether the container has desired power or ability to resist the hydrolysis. And to check this ability, we will perform a test of glass containers called as hydrolytic resistance test. We discussed each and every aspect and steps of hydrolytic resistance test in details. In this video, we are going to check your understanding of hydrolytic resistance test with an example. But before moving further, if you still didn't subscribe to my channel, click on subscribe button and don't forget to click on the bell icon to get notifications of all further videos. Hi friends, I am Amit Belekar and today I will discuss an example related to hydrolytic resistance test of glass containers. After going through this video, the learner will be able to check his understanding of hydrolytic resistance test. Now let's move towards the example. Glass containers made up of type 2 glass having normal capacity of 25 ml are tested for hydrolytic resistance test. Average overflow volume of containers is 29.6 ml. After the titrations, average of ml of 0.01 molar hydrochloric acid required to neutralize leached alkali is 0.5 ml. Then give answers for following questions. How many containers should be used? How much volume of distilled water should be filled in each container under test? That is filling volume. How much volume of test solution should be used for titration? How many titrations should be performed? Whether containers passes the test? Justify your answer. Now use your understanding of hydrolytic resistance test as discussed in previous video, or you can again watch that video by clicking on I button on the top. Pause this video and find the answers for the questions. After finding the answers, play the video and check whether your answers are correct or not. For the answer of first question, that is how many containers should be used, you have to refer this table. As normal capacity of container is 25 ml, we have to use at least 5 containers for testing. So answer for this question is 5 containers. Now move to the next question, that is how much volume of distilled water should be filled in each container under test, that is how much will be the filling volume. We know that we have to take 90% volume of average overflow volume as a filling volume. Average overflow volume in this case was already given, and that is 29.6 ml. 90% of 29.6 ml will be the filling volume, and it is 26.64 ml. Next question is, how much volume of test solution should be used for titration? For getting answer of this question too, you have to follow the same table as follow. As normal capacity of container is 25 ml, we have to use at least 50 ml test solution for titration. So answer for this question is 50 ml. Next question is, how many titrations to be performed? To get answer for this question, you have to go through this table. As container filling volume is between 3 to 30 ml, we have to do 2 titrations. So answer for this question is 2. Now coming to the last question, whether container passed the test, the answer is no. Now you have to justify why answer is no. For that, you have to go through this table. As our container filling volume is between 20 to 50 ml and the container is made up of type 2 glass, the maximum volume of 0.01 molar HCl per 100 ml of test liquid required to neutralize the alkali is 0.6 ml. As per the information given in the example, after the titrations, average of ml of 0.01 molar HCl required to neutralize leached alkali is 0.5 ml. This information is for titration of 50 ml volume of test solution. When we convert it for 100 ml of titration value, it comes to 2 into 0.5, that is 1 ml. So actual result is 1 ml per 100 ml, and acceptable limit as per the table is 0.6 ml per 100 ml. Thus containers leaches the alkali in the formulation more than expectation, and hence container didn't passes the test for hydrolytic resistance. Hope you understand the example and clear the understanding of hydrolytic resistance test. Thank you for watching this video patiently. If you think this video is useful, please like it and share it with your dear ones who will also get benefited from this video. If you still didn't subscribe to my channel, click on subscribe button and bell icon to get notifications of all my new videos. If you have any query, ask me in the comments or on my mail address. Thank you once again and see you soon in the next video. Till then, bye bye and love you.